two speakers separated by a distance d. Okay, so here's our speakers, and here's a distance d of their separation. They are at a distance 3.5 meters from a microphone. The loudspeakers generate waves in phase with a frequency of 800 Hertz. When the microphone moves as shown, it goes up here on our diagram and then down. It detects points with varying sound levels. Determine the wavelength of the sound waves. Determine the distance from the origin to the first order maximum. Then determine the distance from the origin to the first point where the microphone detects no sound. And our origin is right here. That's the origin, right at that place. Determine the wavelength of the sound waves. Well, we still have velocity is equal to lambda f for any type of wave. So lambda, divide both sides by frequency, we get this. Here's the speed of sound, which if you don't remember it should be on your table of constants, divided by 800 Hertz, and we get a wavelength of 0.425 meters. Determine the distance from the origin to the first order maximum. So here's our origin, and we want to find this distance to where you get a first order maximum, which means you can hear it very loud. That's the maximum sound that you'll hear from the speakers. So use the equation for wave interference, and this is constructive interference, where m lambda L over d. We were given d and L in the problem. M is 1 because we want the first order maximum, and we found the wavelength in part A. So we put our numbers in over here, and we get 1.98 meters. So this distance here would be 1.98 meters, and you would hear a maximum sound if your ear was over here. Can I draw an ear? Yeah, there's an ear. You can find other maxima or loud spots when m is a whole number. So you've got the first order, the second order, you'd put m is equal to 2, third order m equals 3, etc. Determine the distance from the origin to the first point where the microphone detects no sound. This time we use the destructive interference equation, and the only difference there is instead of m, we have m plus 1/2, and m will start at 0 and then go 1, 2, 3, etc., etc. So we put in 0 for m, we have our half, we have the wavelength, we have L, and we divide through by the distance between the speakers, and we get the first place where we hear no sound is 0.99 meters right over here. So that's no sound. Then on the previous slide, we found the first place we have a maximum sound is up there.